Welcome to part 2 of week 2 of pre-calculus. We continue today our study of linear functions. We mainly will be looking at graphs of linear functions today. And the first example is simply graph the equation of a linear function. The equation is negative 2/3 x plus 5. So let me draw a coordinate system. Naturally, it is enough to find any 2 points that will lie on this graph, because the graph is a straight line, as we learned last time. 2 points will be enough to draw the line. Typically, it should be a good idea to find the y-intercept, which, remember, is the value of our function at 0, which in this case is, of course, 5. So the graph will pass through the point 0, 5. And then the second point could be either the x-intercept or any other point where computation is simple. Because we have 3 here in the denominator, it seems like a good idea to try x equals 3. So f at 3 is negative 2/3 times 3 plus 5, which is, of course, 3. So the graph will pass through the point 3, 3. Of course, the graph is decreasing because the slope is negative. That is something we should expect. And to be safe, I would still find the x-intercept, even though technically it's not needed. But to find the x-intercept, we simply equate to 0 the expression negative 2/3 x plus 5. And clearly in the denominator we have negative 2x minus 15 equals 0. And so x equals if I multiply by 3, right, I get negative 2x plus 15. So 2x equals 15, x equals 15 halves. So you draw some kind of line. That will pass through these 2 points. Zero, 5, and 3, 3. That point will also pass through the point 15 halves, comma 0, as we found. That is the x-intercept. Now, in the next example, we need to match the equations of 4 given lines with the 4 lines in the picture. It shouldn't be a difficult problem. For example, let me use colors for this. What is the equation of the red line? Well, it looks like the y-intercept, is 3, and the slope is 2 because as you run by 1 unit, you rise by 2 units. You rise from 3 to 5, that's 2. So slope is 2, y-intercept is 3. So that is line A. Now, what about the green line? For the green line, the y-intercept is -3 and slope is again 2. Look, for instance, at these 2 points. Run is 1, rise is 2, slope is 2. So that is whatever line has slope 2 and y-intercept -3, line B. Now the orange line also has y-intercept at 3, and what about the slope? Slope is clearly 1/2. Consider, for instance, these 2 points. The run is 2, and then the corresponding rise is 1. So rise over run gives you 1/2. The orange line has slope 1/2 and y-intercept 3. That is the line 1/2 x plus 3, which is line D. And let us check that the remaining line is line C. The y-intercept is 3. What about the slope? Consider, for instance, these 2 points. As you run for 1 unit, you drop for 2 units. So rise over run, rise is negative, rise over run is -2. So that is the line -2x plus 3, which is indeed line C. All right, that finishes this example. In example 9, we have to find the x-intercept of the graph 1/2 x minus 3. For that, we just equate this to 0 and naturally find that x equals 6. So f has x-intercept at the point 6, 0. We should note that we will also deal with horizontal and vertical lines. Lines that are horizontal, as we know, are of the form y equals constant. And lines that are vertical are of the form x equals constant. For example, this line here has the equation y equals -4. And this line in the right picture has the equation x equals 7. We now look at an interesting theorem. Theorem given necessary and sufficient conditions for 2 lines to be parallel or perpendicular. Remember, perpendicular means intersecting at an angle 90 degrees. The word perpendicular means making an angle of 90 degrees. So the theorem is this. Two lines are parallel if and only if they have the same slope. We already saw this in a previous example, right? Lines A and B are parallel. They both have slope 2. And two lines are perpendicular, making an angle of 90 degrees at their intersection if the product of slopes is -1. Note that both conditions are if and only if. So lines are parallel if slopes are equal, and vice versa. If slopes are equal, lines are parallel. And if lines are perpendicular, then the product of slopes is -1. And if the product of slopes is -1, the lines are perpendicular. This, of course, doesn't take care of the situation of parallel or, doesn't take care of the situation when lines are vertical or parallel. So this here should say that two lines that are not parallel, vertical, and not horizontal. And again, you can see how this theorem works in one of the previous examples. If you look at lines C and D in this example 8, the product of their slopes, -2 and 1/2, is exactly -1, and the angle that these lines make is exactly 90 degrees. So that is the theorem. In example 11, we're given 4 lines. We should identify 2 lines that are parallel and 2 lines that are perpendicular. So we immediately see that lines A and D are parallel because they have equal slopes, and neither of them is parallel to the remaining 2 lines B and C. So let me write this down. Lines A and D are parallel because they have equal slopes. And neither of these lines is parallel to B or C because neither B or C has slope 2. However, we see immediately that lines B and C are perpendicular because the product of their slopes is -1. Also, B and C are perpendicular since the product of their slopes is -1. All right. In example 12, we need to find a line parallel to the graph of 3x plus 6 that passes through the given point 3, 0. We can easily do this because we can use the point slope form, right? We are looking for a line whose slope is the same as slope of this line, which is 3. And that line must pass through the point 3, 0. So using point slope, we can write that the desired line is y minus the y coordinate of the given point, which is 0, equals slope, which is 3, times x minus the x coordinate of the given point, which is 3. And of course, that means that the slope-intercept form of that line is y equals 3x minus 9. Okay, in the next example, we need to find the line that's perpendicular to the line 3x plus 3 and passes through the point 3, 0. Now, again, we can use the point slope form. The question is, what slope should our desired line have? Right? Say it has slope m. That means that 3 times m, the product of the slopes of two lines, the given line and the line we're looking for, which has slope m, must be negative 1. So the desired line has slope negative 1/3. So using the point slope form, we can write the desired equation as y minus the y coordinate 0 equals slope negative 3 times x minus the x coordinate 3. Or in slope intercept form, that will be y equals negative 1/3 x plus 1. Okay, in the next example, we have a line that passes through the points negative 2, 6 and 4, 5. We need to find the equation of a line perpendicular to that line passing through the point 4.5. Let us first of all find the slope of the given line. Remember, slope is rise over run, delta y over delta x. And in our situation, that's 5 minus 6 over 4 minus negative 2. That is negative 1 over 4 minus negative 2, which is 6, so negative 1 over 6. Therefore, the desired line's slope, desired line's slope is 6, right? The slopes of the two lines must multiply to negative 1. 6 times negative 1 over 6 is negative 1. So using the point slope form, we can write the equation of the desired line as y minus the y coordinate 5, through which that line passes equals slope, which is 6 times x minus the x coordinate, which is 4. Or in the slope-intercept form, that is the line y equals 6x, and the free term will be negative 24 plus 5, which is negative 19. Finally, the last example here is finding the point of intersection of two given lines, 3t minus 4 and 5 minus t. And graphically, of course, this will have a clear interpretation. Line 3t minus 4 has slope 3 and intercept negative 4, so it'll look like this. And line 5 minus t has slope negative 1 and y-intercept 5, so it will look like this. So the point we're looking for is the point where they intersect. That is the graphical interpretation. So to find the point at which these two lines intersect, we simply set the two equations equal. Set the two equations equal. Three t minus 4 equals 5 minus t, which is equivalent to 4t equals 9. That means t equals 9 over 4. And to find the corresponding y value, we can substitute for t 9 over 4 in either equations. For instance, in the second equation, 5 minus t will be 5 minus 9 over 4. A little bit of algebra. (11 over 4). So the point at which these two lines intersect has coordinates 9 over 4, comma 11 over 4. And again, the graphical interpretation is that if a system of two linear equations has a unique solution, that is precisely the coordinates of the point at which the lines representing the two equations intersect. All right, this is it for today. Next, we will talk about absolute value functions. Thank you.